Hello everyone, I'm Fatima Sora from Texas State University and I am a mechanical and manufacturing engineer. I work with automated systems and control, which belongs to one of the four pillars of manufacturing knowledge. And my topic is smart automation for integrated water system. Scarcity of freshwater resources is a global problem. As a solution, I'm working on integrating these two off-grid water systems for vertical farming and introducing smart automation to the system. First system is atmospheric water generator or AWG in short, which cools down the air to condensate moisture from surrounding atmosphere. In that sense, it is free, but it is energy intensive to run and inconsistent in nature because the production largely depends on atmospheric temperature and relative humidity. Second system is rain harvesting system or RHS in short, which collects and stores rainwater for future use. So it is free, but unpredictable and variable amount in nature. Vertical farming is a kind of hydroponic farming where the plant roots are submerged into nutrition-mixed water. It consumes only 20% water compared to the conventional farming, and it's grown in a controlled environment which yields better quality produce. But this system needs consistent water supply. So this vertical farming can be a good example of water uses and a test and validation platform for my integrated system. Purpose of my research is first to investigate if this integrated system is better than a single system, in this case RHS, because usually rainfall is higher than the AWG production. Secondly, to introduce smart automation that provides automated control over the system. And by smart automation, I mean AWG is only on when necessary and feasible. First step of my method is to do data analysis to compare rain and integrated system. And in second step, design, development, coding, test, and validation of smart automation. This figure shows the result of my step 1, y-axis being the water production index from 0 to 1, denoting the minimum production from highest production, and the x-axis denotes the months over the years of 2014 to 2017. Green plot shows the integrated system, and the orange plot shows the rain harvesting system. As you can see, the green plot has less up and down rather than the orange one. That means it has less coefficient of variation than the rain. This indicates that this integrated system has better consistency over the rain harvesting system only. My result for second step is introducing automation with the help of Arduino Uno and relay switches. And it has two sides, generation side and the consumption side. Generation side, Arduino takes input from the float of main reservoir when the water level is down. Then it takes input from the temperature and humidity sensor to decide on turning on or off the AWG. The AWG runs and refills this water tank. Consumption side, the Arduino takes input from the float switch of the supply tank, which supplies water to the vertical farming area. Then the Arduino decides on closing or opening the solenoid valve, which regulates the water flow from the main reservoir to the supply tank. This video demonstrates how the float controls the solenoid valve. As you can see, when the water level goes down, the float goes down and the solenoid opens to let the water flow come in. When the water level is back up, the float is up and it shuts down the system. As a conclusion, I can say that the research has shown that there is a good operation feasibility for AWG in most places with water scarcity. And there is high variability in rainfall around the world. So my research of combining these two off-grid water systems smartly can lead to a potential source of water supply at low cost. Thank you.